In example 2, we have several pairs of points, and for each pair of points, we want to find the slope of the line that contains both of the points. So you'll recall the slope is denoted by m, and it's described verbally as the rise over the run. And these terms, rise and run, refer to the change in y, or in other words, delta y, over the change in x, or delta x. And in terms of a formula, this just means in the top, the delta y would be the y-coordinate for the second point minus the y-coordinate for the first point, divided by the delta x would be the x-coordinate of the second point minus the x-coordinate of the first point. Okay, so with all of that in mind, for this particular example, our slope would be, okay, let's, just to make this clear, let's label these. This is the x-coordinate for the first point, and this is the y-coordinate for the first point. This is x2, the x-coordinate for the second point, and this is y2. Okay, so the delta y would be y2 minus y1 divided by x2 minus x1. Okay, now that I have these here, I can calculate this. The numerator, the top, is 9 minus 5, which is 4, divided by 3 minus 1, which is 2. 4 over 2 is 2. So that's the slope for this first line, the line in part A. Okay. Part B, we have this point, and again, we're calculating the slope. And we do this the same way. First off, just to make this a little bit easier, let's label these points x1, y1, x2, y2. And so our slope, m, is delta y, the change in y, divided by the change in x as I go from one point to the other. Delta y is minus 8 minus 7, divided by delta x is x2 minus x1. So that's 3 minus negative 2. You need to be very careful about the signs here. It's easy to make a sign error on this problem. Okay, now calculating these, in the top, minus 8 minus 7 is negative 15, divided by 3 minus a negative 2, that's 3 plus 2, which is 5, and so our slope in this case is minus 3. Okay, let's go on to part C. Same as in the previous examples, our slope is delta y over delta x. Delta y in this case, again, let's go ahead and label these points. This is x1, y1, x2, y2. So delta y is going to be 6 minus 2 divided by delta x, which is 10 minus 5, which is going to give us 4 over 5. Okay, so the slope here is a fraction 4/5. And just as a quick reminder of what the slope means, since the slope here is 4 over 5, what that tells us is for every 5 units, the x-coordinate increases. Our y-coordinate for points on the line are going to increase by 4 units. Okay? Moving on, let's look at part D. Okay, so for part D, our slope, as before, is delta y over delta x. Again, we'll label these x1, y1, x2, y2. So actually calculating the slope, we're going to get minus 7, y2, minus negative 2, that's y1, divided by 5 minus 2. So up top, we have minus 7 plus 2. So that's going to be minus 5 divided by 3. That fraction doesn't simplify any, so we'll leave it like this. And so again, just as a quick interpretation of this slope, if our, say, we are sitting at some point on the line, and then we increase the x-coordinate by 3, what that means, since we have a slope of minus 5 over 3, our y-coordinate is going to decrease by 5. Decreases because of the negative in the slope. So our line would maybe look something like that.